Being biochemist, I'm a major fan of tryptophan, and hopefully after today's 20 days of amino acids, you will be too. So tryptophan is one of the main amino acids that our body uses and pieces together to make various proteins. And we can see where proteins are when we're doing various experiments based on the absorption of UV280 light, so light with a 280 nanometer wavelength. Tryptophan, and to a lesser extent tyrosine and phenylalanine and histidine, are able to absorb UV280 light because of a property called aromaticity. So what these amino acids have in common is that they have these aromatic rings, and so they've got these ring structures in which the electrons are actually being shared throughout. So you've got this electron resonance. And it's happening in a ring, and so when we have molecules with this property, we call them aromatic. The electrons in those rings are living in different energy levels, and they can jump from one level to another. They can get excited upward by the absorption of the energy from light, but only if that light has the right amount of energy to jump them to the next level. And 280 nanometer light has that good amount of energy in its photons in order to excite those electrons up a level. So that makes it so that these aromatic amino acids will go to absorb the UV280 light, and that is then going to allow us to see where proteins are, say when they're coming off a column in column chromatography. Different proteins have different amounts of these aromatic amino acids. So some might have a lot of tryptophan, say, and others not any. And so what happens is that the molecules, the proteins that have more tryptophans, absorb more light per the same amount of mass of protein. And so there's actually a value called the extinction coefficient that you can determine for each protein in order to get an accurate concentration if you have a pure protein. However, if you have an impure protein mixture, then you kind of just take an average. And so there's this typical, what's used is like 1 mg per mil corresponds to an absorbance of 1 unit at UV280. And so if you have a pure protein, however, then you can go and you can actually use that extinction coefficient conversion to get a more accurate concentration. There are other methods that we could use to measure protein concentration as well. So there are Bradford assays, there are BCA assays, various other methods that we can use, but monitoring the UV280 is kind of the quick and dirty way that we can do it. And when your samples are coming off of a column, say, you want to be able to see where they are, where they're coming off, without having to go and run an assay on all the different samples. So that's why I'm a fan of tryptophan, and Tweety Bird is a fan of tryptophan too, because you can say it tWiptophan to remember that the one letter abbreviation for tryptophan is a W.